few things we would like to cover today. We'll finish off with the word problems, and then we'll start on the new chapter. Okay, very exciting fraction chapter. Okay, so yesterday we were at this question on Janice and Siti and Huiling. And I intentionally drew a model here that doesn't seem to quite help us solve the question. Okay? Right. Are we ready? Thank you. So, if you look at this, I really need to say that sometimes, even during your test time or exam time, there may be occasions where you finish all the steps, come to C at the model stage. You try to finish your model C to help you, but at the same time, don't see to help you. It's kind of stuck. You don't know how to proceed on. If I plus these two numbers, it doesn't seem to make sense. And Janice being an overlap seems like a problem. When this happens, never mind. Let's try again and see if there's another better way to draw the model to help us to understand it better. Maybe this one doesn't work. That's why I say sometimes when it's drawing, I prefer to use eraser. So if need, I will erase it away. So let's say if I don't erase this away, because I make sure I have enough space to do more workings, let me use the other side. And let's try to draw a different model that maybe can help us see better. Okay? Okay? Is it okay? Now, imagine I will draw city as that one unit first. Okay, maybe about the same size as the one I drew. Maybe like this, about. And the city was one unit, that was one thing that I knew. And then there was this Janice here. Janice, actually not sure how much it has. But we know that, okay, maybe like how I drew here, maybe it's this size. I'm already not sure what size is hers because it's not really stated. So, but the thing I know about City and Janice is that it's 146. So let's say I draw City, Janice, whole relationship in this manner. City is a bar, Janice is a bar. I actually don't know which one is longer. Maybe after I finish the whole question, I draw the model size is not correct. Like how yesterday, how Ram pointed out that one of the model, the size is not correct, right? So it may happen, but it's because I don't have all the identities. So I don't really know what size to draw. But maybe it's like that, okay? And because there are two different relationships, right? I'm going to draw, say, that's Janice again. Let's just draw Janice. And then Janice, and then we know that Huiling is 3 units. Okay. And then I draw two separate comparison models. One is between City and Janice. One is Janice and Huiling. And then I can see that there's City here compared to Huiling here. Okay. And then Janice and Huiling is 374. Now, let's look at these two different models, right? If I plus this set and this set, what do I get? If I plus the first set of model, look at this one now. If I do 146 plus 374, what do I get? I actually get City plus Janice plus Janice plus Hui. Agree? If I add these two numbers up, this is what I get. Do you agree? Don't copy first. Don't be busy copying. I'm guiding you to think. Later, maybe I will erase everything, and redo. That's what happens when we are trying out solving problems. Who says I'm going to be right? I'm not holding the answer key here. I'm going through this question. So maybe I've drawn finish, I'm all wrong left. But that is what may happen when you're trying out. And you have to be fine with it. Sometimes mistakes happen. Okay? So don't be busy copying. Let's look at this. So if I'm going to add these two numbers up, what do I get out of this? I actually get City plus Janice plus Hui. Agree? Which actually means City will be 1 unit, plus there's Janice, and then plus there's Hui 3 units. So I get 4 units and then 2 Janice. Does it help me to solve the question? Yeah, actually very hard still. Because I have the unitary method, and then I have Janice, and then I have no idea how many units Janice is. Can I guess how many units? I can't also, because it's really not safe. Okay, so this method doesn't seem to work. Okay, how about let's say I try use the bigger number minus a smaller number. Okay, so let's say I try to use here, so no more, this one no more. Let me try use 374 and I minus 146. If I use this big number minus this smaller number, what do you think I will get out of it? Why do you say 2 units? Because can you see? I take this one, if I were to subtract away 46, can you see I'm actually subtracting Janice away? I actually subtract Janice away, and then I subtract. It's just like from here, if I minus this, I'm actually subtracting Janice away and subtracting City away. Can you see that? Because 374 is actually made up of Janice plus 3 units, right? And then if I use subtraction, I'm actually effectively cancelling Janice away and then 1 unit away. Can you see that? So, like Zahir says, I end up actually getting, because this one is Janice plus 1 unit. So when I do that subtraction, I'm actually minusing Janice and minusing City away, which is 1 unit. What do I get out of it? I actually get 2 units. Will be equals to 374 minus 146. Does it give me a way method to solve the question? Does it? So if I were to do this, I will get 228. I can see 2 units equals to 228. Does it get me somewhere? Yes, right? 2 units means what will I have for 1 unit? What is 1 unit? Who is 1 unit? City. I actually managed to get somebody. Can you see that? But just now, if I were to choose addition, will I be able to find somebody? Actually, very difficult to find anybody. Now, if I use this model to draw subtraction, is it easy to see? Not easy actually also. But if you were to look at it carefully, I will be able to actually subtract this portion off. It's like just like saying this portion was 146. Because this was Janice and City. So that overlap relationship, we might need to be able to see. That's why this is a level 3 question. Okay, but you also realize that once you're able to see this relationship, the question actually becomes very simple. So I can find CT by doing division. 228 divided by 2. I get 114. So 1 unit is 140, that's CT. So Janice will be, is it Janice times 3? Is Janice 3 units? No, Janice is not 3 units. Who is 3 units? Hui is 3 units. So how do I find Janice then? Yes. Okay, so Janice will be from here. This part of the model, subtract away CT. So 146 subtract 114. That will give me 32 cookies. Oh, is the answer 32? Anybody got 32 as well? Yeah. Can you see the size of the model is already something is not very accurate, isn't it? So it turns out that Janice is actually smaller, the smaller piece. Right? Okay, so this shows you sometimes the model doesn't work perfectly because it begins with a lot of I don't know how. But when you see a question that tells you there's a lot of things I don't know, start to ask yourself, how can I connect the people together? What is their relationship? You see? Let me mute myself here. Okay, now, so I was saying we need to be able to find out the relationship between our characters to solve the problem. Okay, let's take a look at Aidin. Aidin managed to get 32 as well. Let's take a look at his model and his steps. Okay, anybody has a different model? Come, show me. You see, like I said, I chose the model to try to show the relationships. Sometimes the model that I draw might not directly direct us to the correct method. Okay, let's look at how our friends try. Okay. Okay, let's take a look at Aidin's one. So in Aidin's one, he showed us, it's through a similar model. So city, Janice, city. He did a subtraction here. Okay, so actually the steps are similar. He found that 1 unit here, and then he used Hui Ling's equation model. So he used Hui Ling's part to solve. So over here is 3 units of Hui Ling, and then use Janice and Hui Ling to find Janice. Okay, so that's correct as well. Okay, so here did similarly, actually the steps are the same, but the model is slightly different. So it shows Janice and city 1 unit, Janice and Hui Ling, 2, 3, 4. So he used the idea that I think you mean Hui Ling and Siti, right? Okay, this is Hui Ling. Okay, Zahir. This I think you mean Hui Ling, right? Okay, so Hui Ling and Siti is 1, 2, 3, 4, 4 units. So he helps himself to see that he see this part that's popping up. Can you see that? So he drew this in that manner that you can easily see that the difference is the 2 units. Okay, so quite similar as well. Okay, so we are here. Everybody okay? Okay, this question is really quite challenging. Sometimes it happens in the test. You will take like a little bit more time than usual to solve it because it's a relationship that's complex. Okay, with that, we will stop here. Like I said earlier on, the pages are it's optional, so I'll let you try on your own. Let's move on to our new topic for today, shall we? Come, our friends come. Now, right, so okay, so we are at a new chapter now. Fractions. Have your journal on the table. Okay, fractions was first introduced when you are in primary 2. Teresa, I do not need you to take out the worksheet yet. I need you to have your journal. Here, we are first introduced. Then in primary 3, we had fractions again, and then now at primary 4. Now, 5 minutes to think back. You can draw examples. Okay, anything you remember about these 3 terms. Unit fractions and equivalent fractions. Find a fresh page in your journal. Write down examples. Or draw whatever you remember about fractions. Okay, these are some terms. Unit fractions, like fractions, and equivalent fractions. Write down anything or draw anything at all, what you remember. Come on, 2 minutes more. You should be able to draw something. You mean fractions is entirely new to you? You don't know what fractions are? Come, write down something or draw something. Certainly you have seen fractions, the word before, right? Yeah, so anything. Draw anything or write down anything. It's okay. Never mind. Spelling not very important. Okay, now, whoops. Okay, let me press. Stop share. And I come over here to show you some of our friends' answers, okay? For example, here, oops. Okay, so this is Rachel's one. Okay, he drew an example, okay? And then over here, teacher wrote something about numerator and denominator. So she says in a fraction, there's a portion on numerator, there's a portion on denominator. Nice. Okay. And yes, and here, Jasmine drew an example of fractions. You cut a pizza into quarters cup. Show us your answer. Okay. And then Kaylen, oh sorry, that's my finger. Kaylen, show us you can have a model, a bar model, you can have a fraction disk, and you can also have like a number line, right? Okay, moving on. Okay, oh, Afiq remember the fraction disk too in a way. And there's Charlotte's one, shows you an example of equivalent fractions. She's doing some steps, as an example. Okay. And then, okay, and Mihao remembers these unit fractions. These are unit fractions. It appears on the bar models, right? Yeah. Then, okay, over here, you told me some examples of subtraction and shows you some what one whole and different fractions of one whole. Okay, and come over here, also drawings. Okay, move a bit over here, see different ideas. Okay, and Lisha seems to remember quite a bit. She says here, unit fractions, not very sure whether it's correct, but never mind. The like fractions means they have the same denominator. Okay, that's correct. Okay, let's go on. Take a look at what our friends are drawing here. Okay, moving on. Okay, okay, and oh yes, and right. Okay, some of us are a little shy. Never mind. Okay, what do you have here? Okay, so there's some interesting parts here, and then there's a drawing. Okay, by Aisha. Okay, there's an addition. We'll talk about that very soon. Okay, and then next one. Okay, oh, they mean the same amount. Okay, for equivalent fractions. And here's Aidin's one. Okay, he wrote here some examples of equivalent fractions and then like fractions. I'm not so sure about what unit fractions are, but never mind. Okay. Oh, I never did get to show this part. Okay, let's take a look at this. Oh, okay. And here, Singer is drawing a cloth. Imagine a cloth cut into parts. Okay. All right. Okay. A bit shy about showing. Okay. Oh, all right. Here. Okay. Here you have. Okay. This on the left. Let's take a look at what it may mean later. Okay. Yeah. Some examples from Zahir. Okay. And moving down. Okay. Have I shown everybody? Oh, okay. Here's Trevor's one. Okay. She says this is from the video. Okay. All right. And moving on. All right. Anybody else want to show? Okay. All right. So okay. Back to my desk. Okay. So no matter what. Later on. Okay. No matter what we remember from our experiences from P1 to P. Whoops. Whoopsie. Okay. No matter what we remember from our past experience, from our, let me mute here. Okay, so really, no matter what you remember from the past, it's fine. We are at primary 4 now, and we will be able to refresh our memories of whatever we learned previously. Okay, good that you remember at least something from your past experiences. Be it a drawing, be it a definition, be it how you solve a question. Those are all important experiences. Okay, now I will go through very quickly of what perhaps you will recall from your previous years. Then we will go into talking about today's activity. Okay, today's activity quite fun. I prepared already. Scissors, glue over there. Okay, and my big paper here. So here at primary 2, let's take a quick look for you to refresh your memory. Just now the song also refresh a bit, right? I really like the song. Okay, I can rap it quite well. We had a competition last year, I said, right? So, right. Can we have your eyes on the screen now?
Don't worry so much about the writing on the journal already. It's okay. Come, let's look. At primary 2, this is primary 2. Primary 2, we have these ideas. Understanding fractions through equal parts of a whole. Does this sound familiar? Does the word whole sounds familiar? Yeah? When I talk about fractions, there's this idea of a whole. Part of a whole. Does it sound familiar? Okay. Then you have how to read and write fractions, how to compare and order, and how to add and subtract. At primary 2, you will encounter these two terms, unit fractions and like fractions. Let's take a quick refresh of our memory, what unit fractions and like fractions are. So very quickly, let's look at this example. One of the favorite ones, from primary 2 up, is always the fraction D's and the pizza. Okay? And the other one is the chocolate, which is also a very popular way to remember fractions. So let's use a more quarters, half and quarters, we are all quite familiar. So we understand from P2, fractions represent equal parts of a whole. When I cut up a pizza into 4 equal parts, the whole thing will become 4 out of 4 equal parts. The fraction part is in the middle, and you have 1 equal part of a whole is called 1/4 or 1/4. You name it differently from whole numbers. Now, moving on quickly, then we go on to understanding what unit fractions are. So like how Ming Hao drew his drawing earlier on, now I have on the left side, the bar model, on the right side, the pizza model. Okay, so exactly is the shaded part that is shown here. The left side, one shaded piece of the whole that is cut into different size parts. On the left, is shaped 1 unit. So if I cut the whole, the same one whole into 2 pieces, and I shape one of it, that's got a half, 1/2. If I cut that one whole into 8 parts, that one piece I shape, it becomes 1/8. Can you understand that? So that's when I'm talking about one piece. So like how we just did unitary method. Do you remember the unitary method that we just talked about for word problems? So we are talking about unit fractions, that means 1 unit. And all fractions are actually made out of unit fractions. All fractions. All the different types of fractions you are going to see. No matter is it called like fraction, unlike fraction, mixed number, improper fraction, they are all actually made out of unit fractions. So unit fractions is like the basic building block, like Lego pieces. You know Lego, you play Lego before? So Lego, comes in different sizes. So you have the basic, simplest, smallest form, unit fraction. So like for example, this case, we have the fraction of 3/5 here. Every time we look at a fraction, we ask ourselves these 2 questions. 1, what is the whole? So like how Yu Tong rightly pointed out, if I refer to 1 whole, then I can have 5/5, 6/6, 7/7, 8/8. But they are all different size parts. So in this case, for fifths, I'm looking at fifths. For whole of fifths is 5/5. If I take 3 out of them, then I will have 3/5, which is made out of 1, 2, 3, 1/5, 2/5, 1, 2, 3 fifth. 1/5, 2/5, and 3/5. Do you understand what I'm saying? So you have 3 of the fifths. Okay, so we go on to this, and then there's the song that I just played. I kind of really liked it. That shows you the parts of, and then how parts of the whole, and then how you're going to label it on the number line. We'll talk more about this, which is a very essential skill at primary 4. And then we talk about unlike and unlike fractions. So likely pointed out by Lisha just now, like fractions are fractions that share the same denominator. Okay? So we're looking at quarters, we are quarter 1, quarter 2, quarter 3, quarter, they are like fractions. So at primary 3, it starts to be a bit more difficult. We are looking at equivalent fractions now. Some of us remember, fresh from primary 3, the term equivalent fractions There are skills of simplifying and expanding, comparing and ordering, writing equivalent fractions of a fraction given denominator or numerator only, and then adding and subtracting. So this was primary 3. So at primary 3, we will have look at something like this. Does this look familiar? Okay, it has to. If you're not so sure, time to look back. Okay, so you look at fractions that actually have the same value, the same size, but the parts are cut differently, and the number of parts I want out of them are different, but actually the whole thing, when you count them, look at the size, is actually the same. Okay, but that's given when the whole is the same. Okay, then we talk about on the number line, and does this look familiar? Look familiar, right? How do you do finding the next equivalent fractions? Okay, and in our following few days, in our next few days, we will be doing brain gym to revise on our primary 3. So I have already prepared primary 3 ideas, concepts of how fractions work. Okay, so now we talk about primary 4. Primary 4, welcome to primary 4. Let's look at the lesson objectives, learning outcomes for primary 4 fractions. Because your primary 4 now, things become more exciting. Okay, this year primary 4, you have 2 parts to fractions. First part, mixed number, simplifying mixed number, improper fractions, new term, fancy term. Conversion between mixed and improper, compare and order, sounds familiar, compare order still happening. Adding, subtracting, still happening. Putting numbers into simpler form, still happening, but now with mixed number and improper. And the new one, solving 2-step word problems involving fractions. Ooh, okay. Then there's a part 2. Part 2, there is fraction as part of a set of objects. Fancy term, new one again. And this time, understanding fraction of a set with model and solving using unitary method, very important. Now, do you see why I do the word problems just before we do fractions? The second part? Yeah, that is why. Okay, because we really are focusing a lot on the unitary method now. And it will help us to solve fractions. Okay, so much saying. Anybody feel scared about this topic already? Right, honestly, I also feel a bit scared. You just look at the number of learning outcomes compared to primary 2. Primary 2, you know, it was just a few liners, right? And then primary 3, 1 page. Now primary 4, you have 2 pages of fractions. Very challenging. But I tell you, if you start confidently and have a bit of fun, not so bad, okay? Now here to why I show you the first song, place value. Remember just now we came back for recess, I played you the song. Okay, this boy counting the pairs, and then he took a bite of the pear, and then you count 1, 2, 3, 4, 9, 8, 9, and then you have 90, and then you count to 90, you regroup to hundreds, yes? Right? And then you're looking at these as whole pairs. So from the previous chapter up to division, we were looking at whole numbers, right? 1 whole pair, 2 whole pair, 3 whole pair, 4, 5, 6, 7, 8, 9 pair, 10 pairs, 10,000 pairs. And right now we are able to deal with 10,000 pairs, right? All the way until 100,000 pairs. And then primary 5, we're going to deal with 1 million pairs, right? 6-digit numbers. But so when this comes to the interesting part about maths, what happens when the story tells you sometimes I don't like to eat a whole pear. I like to chop the pear up and share it with my family members. Or simply, I find a whole pear very hard to chew. I want to cut it into parts. And then take my fork and pinch a nice slice. Maybe dip it into some melted chocolate, even nicer. So you have slices, or why not make a pear pie? I pick a pie, I have to cut it into slices. I don't put a whole pear into a pie, right? Correct enough. So you probably want to slice up things. So, but then what would you call this then? I have 3 whole pears. And what do you think this is? That's half a pear, right? Quite clear. This is half a pear. I got chop it half, right? And what about this? Are you sure it's 1/3? Very hard to see actually, right? Very hard to see. Yeah, very hard to see. So we are here to challenge us. Our new activity today. Our activity today is called the Polo Buns activity. Do you know Polo Bun? Don't know. Okay. Polo Bun is a delicacy. Okay, came from Hong Kong. Very nice. If you come out. Sorry. Yeah, yes, correct. Westgate and Jurong Point. Some of the shops sell. And then if you cut it open and you have butter, it's a bit like the Mexico coffee bun. You know the coffee bun? Yeah. And then it's crispy on top. Very yummy. And it's called a polo bun because the top, right? The design, right? The top design looks a bit like pineapple. So polo in a dialect is actually means pineapple. So the design looks like a pineapple. That's why it's called polo bun. Very nice to eat, especially with not the polo t-shirt different. Okay, especially nice to eat when you have butter on it. Okay, now so you have 1 polo bun, 3 polo bun, and then somebody chew on the polo bun, and then that 1 polo bun become half a polo bun, right? Okay, so what now? Now, our activity requires us to sit in our groups of 5, right? So you need, the paper we are using is this giant paper. So we need to join about 4 tables. Okay? Yes, we need to join about 4 tables so that we have enough space for the giant paper. Okay? What are we doing with the giant paper? We are going to stick polo buns, okay, to this paper. First, yes, so first you get to your groups, clear out your tables with, or you need, I should actually cover this part first. You need only your, wait. Let me put this blank first. And Okay, if you're ready, I'll show you an example over here. All right, for example, my first page, I folded my paper into fours, and I'm looking at the quarters in this manner, the long side, and I'm going to be given some polo buns, and the polo buns have a fractions that I have to answer to. So for example, if my polo bun is 1, then I will have 1 polo bun. Okay? If my fraction say half a polo bun, what do you need to do? Okay, 4 and cut, right? And then you get a half a polo bun, right? Okay, are you ready to challenge? Okay, let me move myself here and share my screen. Okay, can I have the group leaders to come here to collect your polo bun? Hey! Take this first. Okay, if you're ready, the first question is on the screen now. Can decide how to work on the 4 questions together. Okay, so I'll show you all 4 questions at the same time. Okay, ready? All 4 questions at the same time. Yeah, it's not exactly accurate, but okay. But however, you have a very good point, right? I would like to say that to everyone as well. Okay, so there are 4 questions. Okay, you can walk around, say who do what question, and check. Okay, I'm going to come around. I'm gonna come around to take photos of you in action. Have you got all the questions written down already? Can you copy down the questions first? Okay, copy down the questions first. Please copy down the questions first. I'm going around to take photos and videos of you in action. Copy down the question first at the side of the paper. Like how I'm showing you the example here. Okay, copy down the questions. Huh? What, why more? Huh?
He's not saying why more to us. That means it's read in exam. Then he's saying I read in exam.
Can we focus on the polo buns now? You know how much time I spent designing this activity? Can you all do something about it? You are not doing it. Can you do on this question? Yes. Okay, I'm coming around to see you in action. Hey, oops. Oh, okay. So can only show faces, is it? Okay, so cannot show the answer. Okay, Travis said cannot show answer. Show faces only. Okay. 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 Very serious person here. Cutting the polo bun up. Very serious cutting up here also. How is the polo bun cooking? Okay. Put some sugar. Okay. Some butter. Okay. Are you holding the butter stick? Is it? Okay. How is it going? Very good.
Done. Okay. Okay, ready? I take photo. Huh? Okay, here's your group members. Come. Photo. Okay, ready? Okay, 1, 2, 3. Okay, done. Okay. Okay, anybody who also done already? Okay, come on over. Okay. Okay, take photo. Ready? 1, 2. Okay, okay. Okay, anyone who also done already? Okay, coming over here. Okay, together. Yeah. Yeah. Okay, ready? 1, 2, 3. Okay. Alright. Okay, hold on, do it first. Okay, this is just level 1. We have level 2 questions coming up. Okay, how is it going? Okay, almost done. Hey, boys, ready, huh? Challenge, huh? Okay, look here. Rachel, is it? Come here. Okay. 1, 2. Okay. 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 Now, those of you who are ready, I'll come over to check your answers. Okay. Okay.
Okay, now looking at the polo bun activity, I'm sure you had some fun. It's still my now I still need to close my lesson. I cannot just play finish and don't know what's going on. Go home, your parents ask you, what have you learned? I learned polo bun. Does it make sense? So what do we do today with the polo buns? It's essentially learning. I'm trying to introduce to you what mixed numbers are. Mixed numbers here. In your textbook, there are some examples. Essentially, there's a whole number part and there's a fractional part. There's a part of it that is a whole number. There's a part of it that's a fraction part. I will talk more about this next Monday. You have a homework to record this down. Write it down your homework now. I did the polo bun with you. In your textbook, there are some examples. The textbook show you pizza and chocolate and water. I show you a polo bun. Now, here's another example. What I would like you to do is try to be creative. Draw me another 2 examples. Give me just 2 more examples of your own. Real life example of mixed number. Okay? Be creative. Can be anything under the sun. I show you a few. I gave you a polo bun. There's a pizza. There's a chocolate. I'm sure you can come up with your own ideas, right? So give me 2 ideas of how you would find mixed number in your life. Okay? On top of that, I would like you to go back and read your textbook. Never mind about the workbook. We'll look at it on Monday. The textbook, page 75 to 80. Can you do that? Just read the textbook. The workbook, we try on Monday. Can? Is this okay? Can you understand your homework? Okay, huh? If you're okay, you pack up your things down and then say goodbye. Which one? Page 75 to 80. The workbook, never mind, we'll do on Monday. Okay? The workbook we'll do on Monday. The cool bits is usual. The textbook, 75 to 80. The journal task is important. Okay? I want you to give me some ideas of your own. How you will see mixed number in your life. Is that okay? Okay, Ken?